Hello everyone, this is Bradley. Today this is a tutorial to talk about these fluffy carpets. The setup is very easy. As always, we're going to use the preset, but I'm also going to show you how to not to use the preset. But the entire point is not the setup itself, but rather to talk about our new hair system in rendering. So let's start. So here in Blender, let's start with a plane and add a geometry nodes modifier. We're going to replace that with a procedural grid within geometry nodes so that we can increase the size freely. Okay, and then I'm going to use the preset called point distribute. The benefit of this preset is it sets the count or amount of particles you generate. If you do not want to use the preset, you can also use the distribute points on face. But the issue is that it's using the density instead of the amount, which means if you decrease the scale of this grid or increasing the scale of this grid, the amount of particles will change. And sometimes when you are instancing some stuff, so point instance, when you're instance on to these points, sometimes you'll crash your computer because you accidentally increasing too much amount of particles. So I'm going to use this point distribute. Okay, so I can set the amount. The amount is not necessarily accurate, but the error is as tiny as possible. So let's just tweak 200 particles for now and make this grid like a 5, 5. Okay, and then we're going to instance some points. The instance is basically hair or curve object. So let's take a curve linear. Curve linear is really just the curve line, and in order to increase the amount of vertices, we will sample that. Okay, so we plug that into the instance. We have all this kind of hair being generated. This is basically the same with the curve linear. I'm going to set that to the z-axis and cancel the center. So this value is determining the length of this hair, and the count is the subdivision. Okay, very simple. And in order to deform all this kind of hairs, we're going to use the realize instance, and to add a noise, we're going to use set position. Okay, to add a noise, we basically just add a noise texture. But if you plug a color into the offset, you will realize all curves go into the positive direction. This is because the color range is from 0 to 1. Okay, so in order to solve this problem, we basically use a vector math to subtract the 0.5 on 3 axes. Okay. But if you think about the real life circumstances, you have to use a lot of noise texture nodes. Every time you have to subtract that, it's a lot of nodes. Not to say there are probably many other things that we will discuss later about the scaling, all these kind of factors. So you increase one additional node for a single noise texture. So instead, I use one node to replace many other dumb math function. So this is noise 3D. We increase the scale. You realize there's a problem. The root does not stick to the ground. So here we are going to use a spline parameter, which is giving a value for 0 to 1 from the start to the end of a curve. And we plug that to fourth. We have two kind of scale. One is a scale, one is a fourth. It's basically just stacking the scaling node to the function. Okay. To animate all this kind of waving animation, what we will do is basically to evaluate all this kind of noise. Since this is a kind of 2D carpets on the plane, so we can use the feature of this 3D noise. So we can see this kind of vector. This is very similar to the shader nodes. By default, there is a position attribute being used inside. If you hover your mouse into that, it says it's not computed. If you replace that into the offset, then you will realize it says it's using the position attribute from geometry. This is basically the default setting. So if you plug the position into the vector, it does not change anything. Okay, this is the same concept when every time you see this kind of custom something in the preset, it's using a kind of default attribute. In this case, it's using the position as well. And what we want to do here is we basically vector math. Okay, we vector math, and to move this noise up and down, then you can see this kind of animation. So you can see it goes to the negative range is flying up, and this is basically the concept. So of course there is another preset which is called translate position, which is doing basically the same function, but the benefit is that I separated the axis and adding some new functions to that. But in this case, you just need to worry about the combine x, y, z of going to the negative range that you make the noise to fly up. Okay, so in this case, let's take a time info node, which is basically just the same time. But the issue is that if you plug the frame into the vector z, then it will be super fast. So you can also plug the seconds into the vector z, then it becomes too slow. So I use a time info node so that you have a factor to manipulate the frames. If you want it faster, then you just decrease the amount because we're using this division. If you want to reverse the time frame, then you just go with a negative. So you can play with all these kind of parameters, but basically this is the setup. This is a very simple setup. Even if you do not use the presets, you probably just plus 1 to 2 nodes for every preset. But it's kind of very simple. But the problem is not just about the setup itself, it's about actually the rendering, the performance. So right now we're looking at all these kind of curves, but if you go to the material preview node, you still visualize these curves. But if you disable this kind of overlay, then you see nothing in the viewport because all these kind of curves are not being rendered. So in order for this kind of curve to be rendered, you have to bevel the curve. And the bevel curve concept is basically a very simple concept that you create a curve and within geometry you bevel that. And to do that in geometry nodes, you need to do the curve to mesh. And just a simple curve to mesh is just making that to mesh. So you need a profile curve, so let's take a curved circle to that. So you give this kind of thickness. And if you are trying to create a kind of UV map, then you need to keep capturing attributes here and there. It's a lot of nodes, maybe 5 nodes in total. So rather I just use the presets bevel curve and decrease the radius. Okay, but here, right now this entire setup only takes like 5.3 milliseconds. It's not a lot, but we're really making a carpet. So we can just increase in the size of this grid, and we need to bump up this size, maybe 20,000. So now we have enough kind of hair particles. And then you realize this setup position is 200 milliseconds and this bevel curve is 120 milliseconds. The exact amount of time it costs to calculate a node tree will vary based on your computer. I'm using a laptop, so like 400 milliseconds is very common, and it's not necessarily slow. It's kind of half second. It is slow, but it's not that bad. At least I get used to that. What's really slow is over 1 second, because every time you change just a single parameter, it will cost 1 second. That's intolerable. Okay, just a personal opinion. But this is not just the end of the story. Let's go to the solid mode, and sometimes I just jump in the endpoint. It will recalculate the node tree, and it takes like 300 milliseconds. If you're trying to play this animation, you have to worry about the frame per second in the viewport. Sometimes that's also an issue that you cannot really preview your animation. You have to improve the amount of time in order to preview the animation and so on. Okay. And that's still not the end of the story. If you look at this setup within the viewport, you will realize the hair or the curve contain a lot of jagginess. It's not a smooth curve. This is because we do not have enough subdivision. We can definitely make that exaggerate. For example, we decrease the subdivision, making that to 5. Then you can realize it's just whatever weird chain kind of stuff. It's not a smooth curve. So in order to improve everything, improve the looking, that you need to increase in the amount of subdivision. But here, if we just go look at the output, you realize it's reduced from 400 milliseconds to maybe less than 200. So the amount of subdivision actually affects the performance as well. So now let's increase that back to 15. Then we take about 400 milliseconds. This means there are multiple parameters that you need to worry for the performance of a setup. One is the amount, the other is the subdivision. And this is still not the end of story. It's not very obvious here because we have enough particles, but sometimes you have to realize there's no floor. So in order to have the floor, you may simply think, hey, let's just add a plane at the ground. Simple and easy. But some other time, people wish to make everything into a single node tree. So they think, hey, why not just use this grid? Let's add a joint geometry at the end. And right now, this joint geometry costs less than 0.1 milliseconds. But if you plug this grid into this joint geometry, you will realize it's very heavy just by itself, like 200 milliseconds. This is because it's kind of recreating a new geometry. So there's no way to improve the performance for this joint geometry. And you realize everything has been just bumped up to 600 milliseconds. Okay. So this gives you a hint that it's not necessarily good to keep everything into a single node tree because joint geometry actually costs a lot of performance. There are many different ways to resolve that. For example, you can simply just not use this joint geometry. As I mentioned earlier, you can create a plane just by shifting A, or there's other methods like using a switch, but I'm not going into that much detail. Okay. So I just want to mention there are many different factors to actually affect the performance. And in order to make a good animation or good render, you have to worry about it. So the question here is, can we really improve this setup? Does the performance have to be this bad? Okay, and this is the real topic for today's tutorial. And we're going to use a similar node tree, but first we're going to delete this joint geometry. We're not going to need that. Another important thing is I'm not going to use this bevel curve. Okay, we're going to use a new system. So now I have a plane. I do not want to use this node tree for now, the moment. I have this plane. I'm going to go to curve, and there will be an empty hair option. This is introduced since 3.3. It's a new curve system. So instead of the old curve system where you have this kind of curve panel, we have a new curve system which is called hair. Okay. Or hair is curve, curve is hair. Okay. So we add this empty hair. We have to use an object to add this hair, which I don't like that. So we will have a child of this plane, but usually if you have watched any relative tutorial, this is relative to the sculpting. So you're using the panels and you add hair with all these kind of brushes. So you paint the hairs onto this parent plane, and you have a deformed curve on surface, whatever stuff. But I'm not going to deal with that. It's not relevant to today's topic. Okay. What I want to really show you, however, is that if you go to the material preview mode, then you realize you can actually see this hair, and you can decrease overlay. You still see all this kind of hair. This is the reason why I'm going to use this curve. This actually means that I do not need this plane. We do not need to bevel curve in order to see this kind of hair or render this hair. I do not need to worry about surface. I do not need to worry about deformed curves on surface. I'm simply going to just switch this geometry node tree into the tree that we have earlier. And you will still see this kind of beveled curve because we intentionally bevel that into the node tree. But we don't have to. We can just delete that. And we still see the hair. Okay. So it already saved a lot of performance by deleting this bevel curve or curve to mesh. But another important thing is previously I mentioned all this kind of jaggedness of all this kind of curve because of subdivision. And within this kind of same panel, there's a curve option. We can increase the additional subdivision to smooth that out this curve without any performance impact within geometry node itself. Of course, you still need kind of base amount of count within your instance. Otherwise, you won't. So you can add a subdivision, but you won't have enough noise to really give a fine detail of your hair. You are only smoothing that out, but it's up to you how to think about that. For example, you have a high frequency noise, then you need amount of subdivision to really show these kind of details. But these are just tiny other things that you may worry about. But just to say that you can add a subdivision to improve the render afterwards, and it's not impacting the performance within geometry nodes. There are some limits yet with this hair system because this is still work in progress. And especially there are some issue with in render or transporting all this attribute into the render, so that you cannot really give every hair a different thickness in eevee. And there are also many other issues. But the good part now is that it can already show kind of a general attribute. So if you take a view in the spline parameter, you will see the bottom is 0 and the top is 1. So it shows kind of black to white from the start to the end of your hair. This also means we can give the texture of that. So let's set a material. And let's add an material. So let's just name that as a hair. So we take this hair, and within shader editor, I can ignore this principal BSDF. I just add a checker texture. Right now, within the material preview node, it looks kind of very ugly. We can change several things, for example, decreasing the amount of values. Another thing, I think it's essentially using the generated textual coordinate, which may or may not be a good option. It does not really matter. We are working with a plane anyway. But some other times you may want to use the UV of your initial geometry. So in this case, we can store named attributes. Because we need a UV, so we take a face corner and a vector. And let's take a named attribute, which is a vector. The UV is supposed to be a 2D vector in the face corner, so 2D vector. This option is added in 3.5. So if you're using 3.5, you will realize the setup here may be a little bit different. For example, there will be a UV map where you can directly plug into this socket. But I'm using 3.4 now. So let's take this UV map and just name that as UV whatever. Okay. So if we want to read the UV, let's just add a attribute UV because we store this name. And we take this checker texture, and by increasing the scale, we have this result. Okay. So this is the checker. Of course, you can add any kind of image texture to this kind of setup, and basically that's how I did. I basically just add a Blender logo into the image texture. Very simple and easy. So basically that's it. And looking at the performance and the details of this setup, it's only 300 milliseconds, and you can increasing the amount of smoothness just by manipulating outside the node tree. Of course, if you want to change the thickness, so here if you add a set curve radius, you realize you're increasing the amount, it does not change anything. But this is because that you have to turn on this strip in order to change its thickness. And since this kind of hair, so by default it's giving kind of the end point for every hair. So it also saves the amount of time that we deal with other whatever stuff. Okay. You can realize this kind of a strip essentially is just kind of a strip. It's not an actual cylinder. But by looking at the distance, you probably won't realize that. There another interesting thing. If we use a different setup, so let's take a curvilinear and point instance, point instance. Basically, this is just the instancing y lines on x-axis, and if we turn off the overlay in the material preview node, you will not see anything. You will not see our hair. This is because you have to realize instance. Okay, and then you see hair, and we can set the curve radius to make it into a kind of a strip. One very interesting thing is you will realize that this kind of strip will actually rotate themselves according to the direction you look for. So this is automatic. You do not need to do additional thing like the clipboard within the rotation. Everything is automatic to make sure that by looking at a far distance, you will not realize that, hey, this is not a cylindrical, these are strips. But I think this is kind of a trivial hair feature because you really need to use whatever method to improve the performance. But it's very nice that this is automatic. Okay. So this is it. I hope you enjoyed this tutorial. I'll probably see you next time. Bye bye.